This lab is called Everyone Loves a Slinky. So in this lab, we're going to be using a slinky to explore waves. Now a wave is sending energy from one location to another without sending matter. So a slinky is a great example of a wave. So what we're going to do in this lab, we're going to go to a place where there's plenty of room to stretch out because we're going to stretch this slinky out to different distances. We're going to stretch the slinky out to 2, 3, 4, and then 5 meters. Then what we're going to do is we're going to send a pulse down the slinky. So one person should be holding the slinky, another person should be sending the pulse. Now what we're going to do is we're going to time how long it takes that pulse to go from that person who sent the pulse down and back. Essentially we're timing a two-way distance. So if we have it stretched out to 2 meters, we're timing how long it takes that wave to travel 4 meters. This eliminates some of the error. Once we know the distance that wave travels down and back and the time it took that wave to travel down and back, we can then calculate the wave speed. So let's go ahead, let's go to a place where we can stretch out this slinky and perform this lab. So now that we've done this lab, we can calculate the speed that the wave travels down the slinky. I'm going to go ahead and put the graph up so we can see the relationship between the length of the slinky and the speed that the wave travels down and back. You can see from the graph that the speed should increase as the slinky is stretched. And it all has to do with what affects a wave speed. Now wave speed depends upon the medium that wave is traveling through. So as we're increasing the length of the slinky, the tension in the slinky is increasing, and that's changing the medium through which that wave is traveling. The next part of this lab is sending a continuous wave down the slinky when it's stretched out to 5 meters. The first wave should be at 1 hertz, basically 1 cycle per second. So every second send another wave. This is what it should look like. The next part of this lab is to increase the frequency to 5 hertz, or 5 waves a second. This is what that should look like. Now once you look at these side by side, you can tell that the waves are different. We changed the frequency. Now we can tell what happens to the wavelength and wave speed based on the wave equation. So look at those two different scenarios. One of the waves is at 1 hertz, one of the waves is at 5 hertz. Using the wave equation, we should be able to determine why this difference is happening. What were we changing? We changed the frequency. Does that change the speed of the wave? And does that change the wavelength? And how does it change the wavelength? So once again, this is Everyone Loves a Slinky.